Okay, well, welcome everybody. I see we've got a few attendees entering the room now, and our panelists are all ready. So we're going to go ahead and get started with our 11 o'clock webinar focusing on Xcel Energy and the Minnesota market, especially as it relates to energy incentives in the compressed air system area. So we're talking with Xcel Energy and the rebate programs that they're offering. And today we've got Brad Taylor, who's our sales engineering manager for Fluid-Aire Dynamics, and also Trevor Kendall, who's our sales engineer out of our Burnsville, Minnesota office. And my name is Michael Heine. I'm the director of marketing for the company. And so pull this all together and try to keep all the electronics working properly. And we're joined by two friends from Xcel Energy, Jeff Kosak, who is the channel development manager, and also Andrew Macho, the energy engineer. So welcome, guys. I see that you're muted at the moment, and that's totally fine. We do have a little video feed going too. So I'll go ahead and turn this over to Trevor. But I do want to remind our attendees that you can use the question and answer button on your control panel and submit questions. And I'll remind you again throughout the session, and we can pick up a few questions and answers at the end. So please don't wait till the end, but please submit your questions as we go along. And so Trevor, I'll let you take it away from here.
Very good. Thank you, Mike. Thanks for pulling this all together, and special thank you to all of our attendees for taking time out of your busy day to join us this morning. I hope this will be educational and helpful for you all. Also want to thank our friends at Xcel Energy, Jeff and Andrew, for joining this morning. Really looking forward to working together more in this region to promote the program and ultimately benefit clients in the region, help to educate them on how this can be beneficial to their bottom line during this challenging time. Just a couple of points here to go through on this slide. Obviously, the whole point of this is saving energy, and Xcel Energy can provide funding to support qualifying audits of your compressed air systems. So that's what this is all about. Obviously, these audits identify inefficiencies and leaks. They also provide recommendations on how to improve your system with new equipment. Anything to add to that, Jeff or Andrew? Be glad for what you guys can fill this out with here.
No, I mean, that's sort of the compressed air study program here at Xcel Energy has been around many, many years. And, you know, it's great to have Fluid-Aire become part of this and working more in line with our customers to really broaden it. And yeah, I think, you know, the compressed air studies, the inefficiencies, leaks, some of those things from a systems perspective really get shook out in these studies. And, you know, the end result really being, let's identify ways to really enhance the customer system as a whole and find those things that can really help customers save money and run their systems more efficiently. So I'll stop there.
Well, that's very helpful. Thanks for giving us a bit of background. Andrew, do you want to briefly introduce yourself and give a little background on what you do for Xcel?
Yeah, I'm the engineer that works on the compressed air program. So I'll review all of the study contents and then create the custom rebate analyses. So we file those with the state so they can get audited. So we're usually pretty accurate on those, and those are used to determine the KW savings that we'll rebate on for custom, and then also maintain all of the prescriptive rebates that we offer.
Thanks for that. Yeah, you've been very helpful on some of the programs that we have worked together on to date. So looking forward to getting involved in some more of those going forward. Just to touch on this slide here, there's two different programs available. We have the prescriptive rebates, and I'll let Jeff and Andrew give us some more detail on that in a minute. One of the big things on that is that all the equipment must be primary and not backup. So you can't get a rebate on a backup compressor. Is that correct, Jeff? Am I stating that correctly?
That is correct.
So that's what that means is if you use a compressor primarily or just only for backup, it's not your main compressor that's carrying the load, that would not qualify. Your compressed air vendor invoices the customer for costs above and beyond what the rebates cover. So what that means is, in the case of Fluid-Aire, we're taking on the risk there on the prescriptive program. It would be deducted directly from what we charge you for the compressor upgrade. And then the work is completed and the customer is paid after submitting proper documentation, or the alternate, a rebate recipient is recognized by the customer. And then the custom rebates, that's for equipment that's over and above 50 horsepower. Anything 50 horsepower and up would fall into the custom rebate program. Anything more that you want to add to that, Jeff?
Yeah, the prescriptive rebates, kind of think of that as sort of a menu item where you do something, you get something. So Trevor, you'll get into some of the specific rebates coming up here, but essentially it's a monetary value for an opportunity that covers those costs and encourages those higher efficiency improvements. Think of custom as the catch-all. Essentially, it's really anything that doesn't fall into the prescriptive rebates that we'll talk about. We can capture potential custom rebates through an analysis process. So think of custom as sort of that basin or catch-all for anything other than prescriptive.
Yeah, that's good. Thanks. That really helps clarify those two different programs. So under the prescriptive program, there's the early retirement program for VSD compressors. So if you have an existing fixed speed compressor, you can essentially get cash for that, which is a pretty cool program. There's the $100 per horsepower, which applies to any VSD compressor under 50 horsepower. And then on top of that, there's the $3,000 early retirement rebate. So by retiring that existing compressor, which means you need to take it out of service and document that it's been removed, you can get $3,000 towards the purchase of a new VSD compressor from Xcel. And I've probably jumped through these points already, but replacements of working in service compressors with new factory compressors from 10 to 49 horsepower. So it's rounded up. Any increments under that are rounded up to the next horsepower. And then the existing system must consist of a single rotary compressor unit serving on a common header. Existing compressor may be equal to or greater than the 20 horsepower, higher than the replacement compressor. Piston compressors are not eligible. So if you've got an older reciprocating type compressor, that does not qualify. Jeff, you could probably speak a little bit more to that, what's entailed there.
I'm going to hand the baton over to Andrew on that one. He's got probably a little more control over that part.
Yeah, so on this early retirement and the horsepower reduction, that $3,000 bonus just has pretty specific requirements on the equipment that's in place, that it is pretty inefficient, and there will be a large amount of savings seen from upgrading. Otherwise, it's just the standard $100 per horsepower, which is a new comparison saying you have these two options, but you're going with the VSD option. So.
Thanks for that, Andrew. I think we can move on to the next slide, Mike. So there's two ways to be eligible for the early retirement rebate. And you must either have an existing load, unload, or online, offline compressor with less than or equal to 2 gallons of receiver storage per CFM of compressor capacity, or an existing inlet modulation with or without blowdown control. And obviously those are being replaced by the newer, more efficient equipment. The horsepower reduction rebate will require documented removal of the compressor, as I mentioned before. And the new VSD compressors, it's kind of a restatement here, but $100 per horsepower for compressors under 50 horse. So an example of that is if you've got an existing, let's say 25 horsepower fixed speed rotary, and you're going to replace that with a 20 horsepower VSD, you would get $2,000 off of the price of the compressor. And then we collect that directly from Xcel. In addition, you would be able to retire that old machine if you're not keeping it as a backup. So you get another $3,000 for the retirement if you're doing that. If you don't have an existing fixed speed, then it would just be the $2,000 for the 20 horsepower. It's just kind of a little case example. And obviously it must be a new compressor and have a factory integrated variable speed drive. So we've got some examples there of the different common horsepowers. And then, as we said before, compressors outside that threshold round up to the next lowest level. You can go on to the next slide, Mike. Benefits of variable speed drive technology. This is something I'd like to bring in Brad on. Brad's had a lot of experience. How long you been with Fluid-Aire, Brad?
Well, the joke around here is I've been doing it since I've been in diapers, but since high school, which makes it 22 years, I guess. But just a couple points on what's just been discussed. Firstly, the incentive rate of that $100 per horsepower and then the $3,000 for the early retirement. It's one of the most generous programs that we've seen in the 3 markets we serve here in Chicago, Milwaukee, and Minneapolis. So take advantage of it. Here in Chicago, we get $85 per horsepower with no early retirement. The Milwaukee market, $45 per horsepower. So very, very generous what Xcel is offering here. So the question we often get asked when we mention variable speed drive or recommend it, that a customer install it, at least one on their system, is there's several benefits. Firstly, obviously the energy saving side. The way the incentives work compared to some of the other regions is it's demand reduction for the Minneapolis market, which means that if I can eliminate the inrush on startup or the plant startup first thing in the morning, if I can lower that with a variable speed drive, that's one area. Obviously the continuous demand is a kWh savings that's forever part of the history of having a VFD installed. Other advantages include reduction of noise, longevity of motor bearing or air in life. How about reduced heat? Those are some of the advantages. When you consider the inefficiency of compressed air being only 10 to 12% efficient, a majority of that is heat. And by only delivering the exact amount of energy put it into the package to match the output demand of the system is where we get our efficiencies. So the inefficiencies are through a couple basic control modes, which were just previously mentioned, load, unload, and modulation. Load, unload is probably the most common. It's been around for decades. Unlike a piston compressor or a compressor that's up to 10, maybe 15 horsepower, where you can operate it through a means of a pressure switch, start and stop the compressor. That doesn't happen with a rotary screw, largely because rotary screws have been used for larger horsepower requirements, 15 horsepower and above. Today, we've seen them come down to as small as 3 horsepower. But when we're talking 15 horsepower and above, we start the compressor and it constantly runs throughout the period of the day until it's turned off. So the control mode used is a load unload type scenario where we open the inlet valve, let air flow into the compressor, and stop that flow when we get up to line pressure. That's great, and it works well. When the compressor's unloaded, you know, you're dropped down to about 25 to 35% of your full load intake kW. But if you multiply that unloaded kW times the duty cycle and the hours during the day, it's very easy to compute the unloaded waste. And a variable speed drive, because it matches the input to the output, virtually eliminates all that unload. In scenarios where you're running a very high duty cycle or you're using a fixed speed as a base load machine, that is the most efficient way to run a fixed speed compressor. Now, the other control mode previously mentioned was modulation. Again, can be very efficient above 80% load, but becomes very inefficient down at the lower end of the duty cycle scale. And the reason for that is instead of loading and unloading the compressor, where we're able to manage the compression ratio of the intake versus the output, what happens with modulation is we throttle or choke off the intake, much like we do with a throttle plate on a carburetor or an inlet valve on a car. What happens though is that the compression ratio between the modified inlet, if you will, and the discharge greatly increases. When that happens, there's an immense amount more horsepower or kilowatt required to produce that compressed air. So below 80%, the efficiency of a compressor in modulation mode drastically changes. So a better way to modulate or maintain a constant pressure while varying the flow is by utilizing variable speed technology. That's the short of it, Trevor.
Thanks for that, Brad. That's a very in-depth overview. Mike, do you want to move on there? Okay, good. So a couple other items that Xcel offers rebates on are the no-loss air drains. And essentially how that works is it doesn't bleed off air, it only bleeds off water. There's a float and a sump. Once the sump fills up with water, it automatically opens the drain and empties out the water that's in the drain. Very efficient, and there's some very reliable zero loss drains out there. And so Xcel is offering a rebate that almost, well, covers probably roughly 2/3 of the cost of the actual drain. The mist eliminators, Jeff or Andrew, do you want to speak a little bit about what's involved with those?
Yeah, the mist eliminators we rebate on, there's a reduced pressure drop is what we base our energy savings on, but there's other benefits like the not changing filters as often and better filtration. And then something else regarding the no loss air drain is good to submit the labor with that, because otherwise rebates do get capped at 60% of the cost we receive. So if the labor cost to install isn't submitted with it, it might get capped at below the $200.
That's good. Thanks for clarifying on those, Andrew. Mike, we can move on, I think, to the next slide there. And then just to touch on cycling refrigerated dryers. If you're installing a dryer, it's good to consider whether it's going to be beneficial or not to do a cycling style dryer. There's several different types of those on the market. Brad, do you want to speak a little bit to the detail of what's involved with the different dryers?
Yeah, sure. So typically we dry our compressed air with two different types of dryers, either refrigerated or desiccant. I think we'll talk about how to conserve energy on desiccant dryers in another slide, but when we're talking specifically about refrigerated dryers, there's three different types. You got your non-cycling, which essentially is a refrigeration circuit that constantly is running, and then we bypass a bit of the hot gas into the cold side to regulate or maintain my dew point between 38 and 42 degrees. Again, it's very wasteful because we're using some of that expensive energy to compress the Freon gas, only to bypass some of it to maintain the temperature. It's very typical to see this type of dryer up to 200 CFM. After that point, we have options, two of which you just mentioned, cycling type and variable speed drive. The cycling type uses the means of thermal mass, whether it's ice or a chilled glycol solution in a large tank, or could be some type of a sand or a block of aluminum. All creates a mass, a thermal mass that's refrigerated down to just below or just above freezing, 32, 31, 33 degrees, depending on how much oil's in the compressed air. And will actually turn off and allow that thermal mass to heat up until the set point, typically about 42 degrees. So much like your refrigerator at home, there is energy savings that pertains to having that refrigerant circuit off when it's not needed. It also gives energy saving in the evening hours when the system is not running. You can leave that refrigerated dryer on, and it'll remain in standby or off a majority of the off hours there, and ready and chilled down for when work resumes the following morning. My favorite though is variable speed drive. Again, it is a very, very simple refrigeration circuit with no hot gas bypass valves. Doesn't have any large glycol tanks, doesn't have expensive sand or aluminum thermal mass blocks, and we're able to vary the speed of the refrigeration circuit and maintain my dew point right at that borderline freezing point, 33 degrees, if you will. And it gives a very dry quality of compressed air to the manufacturing operation, in some cases eliminating the need for desiccant dryers. Powder coaters come to mind. They are right on the borderline of requiring desiccant compressed air. In fact, many of our customers use them as a precaution. With hydroscopic materials, it's important to try and keep that dew point as low as possible, but it's also a balance with how much energy I want to consume. So that's the overview on refrigerated dryers.
Very good, very helpful overview. Dryer purge demand controls. So Andrew, you could probably give us a bit of background on what's involved there and how this can potentially benefit the client.
Yep, so this is on the heatless desiccant dryers, where we offer the $1,500 if you have a dew point demand controls or something equivalent on those new desiccant dryers if they're heatless. If they're heated, you can go through custom or any other type of desiccant dryer that isn't heatless, and we'll offer rebates on those. It'll just require custom analysis through a study.
That's
so
good.
Think of demand purge controls as making your dumb desiccant dryer smart. Most desiccant dryers, especially under 200 CFM or arguably even 400 CFM, simply come with a timer, valve switching control timer. Okay, it doesn't care how dry your compressed air is. It just will cycle those towers typically every 10 minutes or whatever the timer is set for. Usually, demand controls are an option at the time of purchase. Yes, they're costly, typically anywhere from $3,000 to $5,000 for the control. A large portion of that cost is in the hydrometer itself, which requires calibration. But consider the cost of operating a desk and dryer. Compressed air at 10 cents per kilowatt costs about $45 per kilowatt per shift. I'm sorry, $45 per CFM to produce per shift annually, okay? 2 shifts, multiply times 2, 3 shifts times 3. If you're 24/7, multiply that times 4.2. When you take that and multiply it times the demand of a desk and dryer, which is typically about 15% of the capacity, not what you use, but of the capacity of the dryer, it adds up to tens of thousands of dollars in many instances. So when you look at the balance of adding some more complex controls that are going to save a lot of energy, that are incentivized by Xcel, it really makes the case a no-brainer. So do the math, 15% of a 100 CFM dryer is 15 CFM that's no longer usable in the capacity of your system. So you just made your 100 CFM compressor an 85 CFM system. Okay, you just took 4 horsepower away of your system. And multiply that 15 times that number I just gave you of $45 per shift. It stacks up to a lot of money quickly. And in many cases, the ROI is less than a year. When you get above 400 CFM, typically it's standard. Typically, the plants are savvy enough and have an understanding. But we're bringing this to potentially smaller operators that need to know this information so they can make educated decisions the next time they purchase or want to retrofit their controls, which is very easy to do, which we could discuss offline in a phone conversation or on-site review.
Thanks for that, Brad. That was very helpful for me as well, just to get a better in-depth understanding of how that can save money. The custom rebates, I'm going to draw on Andrew for this as well, but I think I just want to emphasize that the best place to start on these is to have a compressed air study, which is something that needs to be done through Xcel Energy on the front end, and possibly do data logging as part of that study to identify what equipment's going to best be suited to optimize your energy use. Andrew, do you want to fill in on this and give some depth to it?
Yeah, so the studies that are generally required by this, as you can see, we give $400 per marketing KW saved. And the marketing KW is essentially what we come up with as the max KW saved or an average KW saved over the operation of the new equipment. It's $400 instead of the $50. So we really try to get everyone to do those studies so they get that full $400 and really drive towards that. And in that study that we fund, we do require the data logging of at least 7 days, and at least on systems that are 50 horsepower or more. And there will be a lot of energy conservation measures recommended within that. And we require leaks to be identified and those leaks to be fixed. And that helps us be able to fund those studies. And it's all in the application of all requirements and what would be included in those compressed air studies. But really, once we have that study in place, it essentially really gets you an idea of what those custom rebates are going to be. And then after that, you would submit that custom project and get your pre-approved rebate amount. But usually those energy conservation measures within those studies are pretty accurate unless loads change.
That's very helpful. Brad,
Guys,
anything else you want to?
this is Mike. I just wanted to ask, since I'm a marketing guy and I see the word marketing KW saved here, I've never heard of a marketing KW before. So can you explain that a little bit more in depth, exactly what that means, Andrew?
Yeah. So it could be, it could be many things. It could be the max bill savings that a customer sees. It could be their demand or based on demand. And then it could be just average KW saved kilowatt hour divided by the hours. It could be a few different ways to get to that average KW, but we try to find that max and maximize that rebate. So that's why we kind of call it the marketing KW, is it's not any specific KW. It could be saved. It could be a multitude of ways we arrive at it.
I see. Thank you.
I think we can move on to the next slide, Mike. So if you're looking as to how to participate, we'll help you through this whole process, and Xcel will be a big resource as well, obviously. But you want to clearly document the proposed equipment and technology specs, and then work with whoever your compressed air vendor will be, and complete the custom efficiency workbook. And then we'll be able to help you complete the whole application process. There's not a lot to it on the prescriptive program. In fact, we do all of it kind of behind the scenes. So not a lot of involvement on your part there, but on the custom rebate program, there's a bit more to fill out. And then once that's been approved, the project is completed, Xcel Energy will verify those energy savings, and it'll be paid out upon the completion. Andrew, anything that needs to get clarified there?
I think that
Good
pretty much covers.
Okay, good. We can move on to the next one. So how to qualify: you must be a real retail rate paying electric and or natural gas business customer of Xcel Energy. And then for the prescriptive rebates, you can just provide an invoice from Xcel Energy that was within 12 months of the purchase date. Then for custom rebates, you need to do that before you actually order the equipment. So pretty straightforward, but just want to make that clear for everyone.
So Trevor, you mentioned on the prescriptive rebates that the invoice is not from Xcel. The invoice must be for the equipment or the service that's being provided, and then that is submitted to Xcel for rebate. Is that correct?
Well, on the prescriptive ones, we actually take that off of the purchase price of the compressor and then work with Xcel directly on that application and get payment from Xcel, so the customer never ends up paying what the rebate amount is. Does that help clarify it, Mike?
I think so, yes. Thank you.
No problem.
Yeah, and just to note too on that, the 12 months, and we understand in many situations, customers are, purchasing prescriptive components, and there's other things that may follow. And so we do allow that 12 months. As Andrew had mentioned earlier, you purchase a piece of equipment and perhaps it's 9 months down the road, you find an opportunity to do a physical install. So the 12-month leeway is for that purpose. But at the end of the day, once the project is operational and the application is submitted with the invoicing, all the invoices that become part of that project need to be within that 12-month window, just to clarify. And that would include physical labor that might be performed by the company installers themselves. As long as it's noted, we can use that as part of the basis cost to allow for the full rebate, so it doesn't cap at that 60%.
That's helpful, Jeff. Thanks for bringing that in.
And also regarding the prescriptive process you mentioned, it does require the alternate rebate recipient, which was mentioned earlier, to be filled out. So it directs where that rebate does go. Because normally without that filled out, it does go to the customer. But if that's taken off of the upfront, then it'll need to be filled out that way. So.
Sure. That's a good point. Should we move on to the next? There we go. Just some examples of rebates that you might want to consider. So 50 plus horsepower VSD compressors, the savings on those can get pretty large. So definitely something to consider. Flow controllers for pressure reduction, master system controls. Brad, do you want to speak a little bit to what's involved with the master system controls?
Well, just on the second and third point, the rule of thumb is every 2 psi we can reduce your plant pressure will save you 1% in energy. Again, that's a rule of thumb, should be data logged, especially for a larger system, and it can amount to thousands of dollars with a few button pushes. The master system control is another component to that. So some of you may have heard of the term cascading or pressure cascading, and that's where you're trying to match compressor ranges within another compressor's pressure range. And what you end up with is a pressure range that's, rather than 5 or 10 psi, if you have 3 or 4 compressors, the pressure band can be upwards of 25 or 30 psi. Well, that potentially means that you could be overpressurizing your system by 25 psi or whatever it is. Typical pressure bands don't need to be much more than 10 psi if we have low pressure drop filters and a sequencer controller. We add a variable speed drive component to that, we can tighten up even closer. What a master system control does is it's one pressure transducer that's now operating through logic, the control at which certain compressors come online. There are certain controls that get more and more sophisticated for the more dollars you spend that will actually learn your systems. In some cases, they'll actually even tie into large processing machines that'll turn on a compressor prior to that operation happening. So it's adding a level of intelligence to your system. I usually steer people clear of them if you have a 2-machine setup. If you're trying to get it just for a time clock functionality or some visualization, there's a lot simpler ways to do it. When you get into 3, I try and find ways around it. When you get above 3, it's pretty much mandatory if you want to have good control in your system. Now, the reason I steer people away from them if I possibly can is because there's a lot of setup that goes into them. And once they're set up, they generally get forgotten about very quickly, or personnel changes within the maintenance organization. And what happens is they end up getting put into a standby mode or overridden or put into a manual mode. And now you're just spent $10,000 on a sequencer system that's no longer delivering savings. So be cautious. Simplicity is best, but can deliver a lot of savings if they're set up properly.
Thanks for that, Brad. That helps understand what the real benefit is of going through these rebate programs. There's other equipment and systems that may be eligible for the custom incentives. Just to touch on those briefly, you might have a blower system for drying off parts or some other process in the facility. Fan systems, hydraulic systems, pump systems, and vacuum systems. Often those are tied in with processes that use compressed air. So good to note those points.
Trevor, just to note as well, in the previous slide, sorry, Michael, if you could just step back one just for just a second. When we talk about other equipment and systems that might be eligible for custom incentives, that's very true. Additionally, just to note, where we offer funding for what we've discussed, compressed air studies, we do also offer funding for compressed air demand as well. And I think a lot of these systems sort of fall into that demand side, perhaps, of the compressed air. If not individually, as they are set up as a system, we can offer demand studies where it's not defined here, but we do offer potentially 75% of the study cost, not to exceed $25,000. So I just want to put that out there to let you know that there's additional funding beyond, just the typical compressed air study funding, prescriptive component rebates, custom rebates. There's also demand side funding capabilities. That's something that if anybody has those opportunities, we could certainly discuss further offline.
That's really helpful. Thanks for mentioning that, Jeff. Just on that point, to clarify it, so that would apply if somebody's going to make an upgrade to a machine, maybe that has air use within the machine, and there's like a control upgrade or something for that machine, or a different method that would use less air. Would that be accurate?
Yeah, correct. And again, it depends on the intricacies of the system itself. If it's pretty complex, where it really needs more of a deeper dive approach to really understanding what's happening and what the solution might be to resolve, to add efficiency to it. That's where an additional study, a demand side type study or an engineering study could come into play. And then as a result of that, then the defined opportunity would be identified. And at that point, we would start to review that through the custom efficiency program. So it's a different funding strategy than the compressed air study, but yet allows for more of that in-depth look if a customer has that need to really review their entire system beyond just compressed air.
Okay, great.
I don't know if
that helps me understand better. Mike, how are we doing for time?
We're doing well.
We
are. We don't have any questions at this point from our attendees. And I am reaching out. I want to see if you guys maybe want to cover data logging and just talk about that and what that brings to the table. I don't know if that's worth it, but in the meantime, I've got a question for the Xcel Energy folks, and that is that we do a lot of leak detection and repair in the Chicagoland market with the ComEd programs, and I'm wondering where leak repair and detection and repair falls into your offerings there. So I wondered if Jeff or Andrew might be able to explain that to us a little bit.
Yeah, and that's with the compressed air study we had mentioned at the beginning. That's considered the supply side, and we fund up to 100% of that within the designated guidelines, which is on the application for funding. And that has the leak detection and the leak fixes within it, and that's where we would claim those. And if there's additional leaks found afterwards, we can do those supply side compressed air studies every 5 years for a customer. And if within those 5 years there's another leak test done and there are different leaks and you fix those, we can also claim those. We don't specifically offer rebates on those leak fixes unless there's a large capital cost that would push the payback longer than 9 months. Usually the leak fixes are a pretty fast payback, and they'll pay back much quicker than 9 months.
So when you say that that's included in the study, is that as if it's part of the cost of the study, is the cost of the detection and the repair of the leaks in a system?
Yeah, it's a requirement for the study provider to do that leak detection. So it does include, it's meant to include the cost of that. However, the actual fixes that are done are not part of the study cost. Those are an additional cost that we wouldn't cover.
I see. Thank you. I wanted to clarify that. Anything else that we can cover here? You guys, anything else to say? Brad, do you think it's worth covering data logging, or have we covered enough of that at this point?
We could briefly touch on it. So we've all heard the term, you can't manage what you don't measure. And that's very, very true. Even with the 22 years that I have in this industry, I still go in armed with a set of data loggers, because the fact is that none of us know how the dynamics of that system look until we put some loggers on there and measure a minimum, in my opinion, every 5 seconds. It reveals quite a bit when you look at data logging. It reveals your peak events, of course. It'll show what your average flows are. It'll show whether additional storage could help bring down those peaks or the peak average. But it also shows what we were just discussing, and that is leakage. Leakage is so costly. As you can see in these graphs here, the early morning or late in the day when production's throttled off, what's left is continuous demand, most of which we typically see is leakage out of couplers, institute fittings, slit hoses, cup seals inside of MAC valves, solenoid valves. All these things consume compressed air. The Department of Energy tells us that they see an average of 35% leakage. We have verified that many, many times and typically see between 25 and 50% leakage. And sometimes we see upwards of 70. The biggest offender to that is dust collectors. Those pulse valves that are outdoors, cold winter day, nobody wants to go out and inspect them. They freeze up, diaphragms tear or chip, and boom, you got 200 CFM of compressed air blasting inside of a baghouse that no one hears, and yet people are wondering where the pressure's going. So I'm really glad to hear of the program through Xcel for leak repair. It's so imperative that there is a leak repair program within every organization. And if you don't, ask your compressed air provider, and hopefully that's us, to help you with that, or even train your staff as to how to do it. Or in some instances, we'll do the identification using our ultrasonic meters and tally up and tag those leaks for your own staff to repair. So that's something that data logging shows, but it'll also show you what energy could be conserved by using different types of technology, whether it's turn valve type compressors or variable speed drive, or maybe a smaller base load compressor to eliminate its unload time. It could also help us identify what your continuous load is on desk and dryers, how much that's consuming. So we've added a component to this measuring, and we now say you can't continuously manage what you don't continuously measure. And we're just in testing now of a device that you'll be able to put on every one of your compressors that will tally up on a homepage and show you what your compressed air demand is, what the efficiency of your system is, what the last 24 hours leak rate was, but it'll also help your maintenance staff understand if there's any potential heat-related shutdowns, motor bearing temperatures, things of that nature. So very powerful tool that allows you to keep on top and set thresholds for alarms that you can manage your system with. So stay tuned.
Very good. Well, we don't have any other questions from the audience. Is there anything anybody from the panel would like to add to this before we move on with our days? Okay, so hearing none, I would like to thank Jeff and Andrew for participating and helping us pull together this information. We're all learning about the intricacies in the Minnesota market for this type of incentives, and we appreciate you being there, and we welcome any of the viewers of this content to reach out to either Jeff or Andrew or a member of our team to talk to you about incentives and ways to save energies and to receive rebates for those efforts. So with that, we'll wish you a very good day and thank you for joining us.
Thank you.
Thank you.